In this video, we're going to look at solving systems of equations using the elimination method. Our essential question: how can we solve a system of equations using elimination? Well, we'll first start with an important definition: additive inverses. Additive inverses. Additive inverses are two terms that sum, that is add, to 0. Examples: -4 plus 4 sums to 0. Therefore, we say -4 and 4 are additive inverses. We often say opposites. They're the same absolute value, but they're opposite signed. Therefore, when we add them together, they make 0. Another example: 5x plus -5x. That equals 0. Thus, 5x and -5x are additive inverses. One final example: -m plus, you guessed it, positive m equals 0. -m plus positive m are 0. Therefore, -m and positive m are additive inverses. So, let us look at a system of equations that we can solve with the elimination method. Problem: 2x plus 4y equals 6. 3x minus 5y equals -13. This is our system. A system is two equations with the same variables. We have x and y in this case. Two equations using those two particular x and y's. Alright, we're going to learn a three-step process. Step 1: multiply to get additive inverses. Multiply to get additive inverses. So we have our two equations: 2x plus 4y equals 6, and 3x minus 5y equals -13. As the name would suggest, elimination method, we're going to attempt to eliminate one of these variables. We can't simply throw them away. It would be nice if we could get this situation where we had a -m and a positive m, or a 5x and a -5x. Well, we don't currently have that, but what we can do is multiply. We can multiply by something, one constant term on both the left and the right of either one of the individual equations. So what I'm looking for is a least common multiple. Think back to the days of finding common denominators. What is the least common multiple between 2 and 3? Well, 6. Likewise, we could try to eliminate the y term. What's the least common multiple between 4 and 5? 20. So I'm going to attempt to eliminate my x terms here. 2 times what yields 6? Well, 2 times 3. So I'm going to multiply the entire top equation by 3. Similarly, 3 times what gives 6? Times 2. So I'm going to multiply the entire bottom equation by 2. However, we need this opposite sign situation. Since these are currently both positives, I need to multiply one of these by a negative. Well, I'm going to choose to multiply the bottom by -2. Okay, so multiplying the top equation by 3 and the bottom equation by -2 yields the following. 2x times 3 is a 6x. 4y times 3 is a 12y. 6 times 3 is 18. I've multiplied the whole first equation by 3. Now I'm multiplying the entire second equation by -2. 3x times -2 is a -6x. -5 times -2 is a positive 10y. And -13 times -2 is a positive 26. So that's step 1. Multiply to get additive inverses. You see now we have our additive inverses. So when I go adding, which will be the next step, 6x and -6x, they will add to 0, thus eliminating my x variable. All right, step 2. Sum. I'm simply going to add down my columns over here. Well, as the name would indicate, 6x and -6x, they eliminate each other. Actually, they add to 0 as their additive inverses, but I won't have to keep that with me. 12y and 10y become 22y. 18 and 26 is 44. So I simply added these two equations together, which is perfectly legal. If we think about what we do to an individual equation, we say whatever we do to one side we do to the other. Well, since the left and the right sides are equal, it makes sense that we could add two equations. All right. After summing, we will step 3. Solve and verify with substitution. So we're going to solve and see that indeed that solution satisfies our system. All right, we have 22y equals 44. I will divide by 22 on both sides. 22 divides 22 to leave y. 44 divides 22, that is 2. So now we have that y is 2. We're going to take this value, y is 2, and substitute it in either of my original equations. I'm going to substitute it into my top equation, pardon me. So the top equation stated 2x plus 4y is equal to 6. I know that y is 2. I will substitute that value in for y. So now we have 2x plus 4 times 2 equals 6. Well, 4 times 2 is 8. We have 2x plus 8 is equal to 6. Solving for x, I'll subtract 8 on both sides. The 8 subtract, leaving 2x. 6 minus 8 will be -2. Lastly, dividing by 2 on both sides. Therefore, x is -1. So, we have x being -1. We have x is -1 and y is 2. I'm going to take those two values and substitute them in using my calculator. Now into my original equation. 2x plus 4y is 6. 2, open parentheses, x being -1, plus 4, open, we believe y to be 2. We hope that's 6. And it is. Into the second equation. 3, open parentheses, -1 for x, minus 5, open parentheses, 2 for y. We hope that to be -13. And it is. Therefore, we see that -1 and 2 is the solution. We'll make this final statement. Since -1, 2 satisfies both equations, it is the solution to the system. There are an infinite number of points that satisfy our first equation, an infinite number that satisfy the second one, but this magic point right here is the only one that satisfies both of them.